So hi everyone, thanks very much for coming. My name is Matt Zito. I'm an architect with BMC Software. Has anyone heard of BMC Software before?
Yes.
Yes. I first off apologize for any opinions you may have about BMC Software. BMC, we make a lot of different products. We make software that helps companies manage their IT. I'm in the cloud group. The cloud group is who's represented here. We make software that helps traditional enterprises manage things like automation, cloud deployments in as agile a way as possible. So what we're demonstrating here at our booth is we've got some integrations between some of our products with things like Chef and Puppet. So if you want, you can build your infrastructure in a very agile fashion using Chef and then control the release, the QA, the provisioning, the auditing, and the compliance of that in a sort of more traditional IT fashion to make your auditors, your compliance folks, your security teams happy. So we're really happy to be here. We're really happy to be sponsoring the show. And thanks a lot for coming out. I'll turn it over to you guys. Thanks very much.
Hi, my name is Dan Robinson. I'm with the automation consulting team with Chef, and we have joining us today Ankush Jantik and Robert Croteau from GE Capital, and they're going to talk with us today about complex. Excuse me. And they're going to speak with us today about Chef and their infrastructure and some things that they've learned using Chef within their infrastructure. So without further ado, welcome.
Thank you.
Thank you.
Thank you. Can everyone hear me? Great. Awesome. Just go to the next slide here. All right, so we're going to talk today about, we'll give you a little bit about us. We'll talk about the Secure OS that we've deployed here at GE Capital. We'll talk about some node discovery, the standardization ontology that we've done, and the promise to keep secrets secure within GE Capital. So about myself, I've been with GE for about 5 years, and I like to say I grew up in IT. I started at the help desk, I did desktop support, then I went into systems administration, architecture, and here I am now. So, and that journey's kind of brought me here to GE with Chef, and we've been using that for about a year now to get our continuous delivery pipeline off the line and to streamline and automate our Secure OS.
Yeah, hi everyone, I'm Ankush Jantik. I have been working for GE about 17 years plus. In that journey, actually, working for GE is really a cool thing. Within these 17 years, I not even spent like three and a half years in the same role. I always moved over to a new challenge, new things to do. I started as a bank card system development lead, and then after two and a half years I moved over to a SOA architecture group and led some SOA development. As part of that, I designed and developed the internet-facing application, internet banking with all of the transactional capabilities, and then moved over to the mobile space, so built a mobile application with all of the electronic purse kind of payment functionalities as well. And a couple of years working on that SOA environment, I realized, well, it's really cool, but it's better if you do that in the large scale. So I moved over to an HQ role and established an SOA community and architecture around GE globally, and built a global ESB, which serves a lot of countries with standardized services, and then move over to another challenging area, a little bit deeper dive of the SOA space that, I realized, okay, so we have the services, but we need some kind of structure in it. So the web service design, database design, it's a really important and interesting area. So I started to investigate a little bit on the database design space. And then I arrived to this Chef's area, which basically contains all of the things together, and it's really cool, dynamic stuff. So I'm part of the ARCOPS team in GE, and works on a lot of challenges at the moment.
It's promise theory.
Yeah, so this promise theory. So basically, how many of you heard about the promise theory before? Yeah, so a lot of. What we try to do today is not, speaking about the promise theory. I more like to cover the way how we use it. So basically, a couple of things that helps us to solve some problem, identify some design principles that move forward, create some standardization around the cookbooks, and how we can keep all of these things like solid and repeatable and actually replaceable in regards of some flavors of architecture components.
So at G Capital, we were going down the road of how do we change IT. And if you see here on the slide, we had some principles and we had some challenges. We had to move to an agile-based development role, global distribution across a large enterprise, infrastructure as code. We needed new naming standards, coding standards, application nodes under one umbrella, security, identification, transmission, without compromising the need to automate our infrastructure. So we also, Akash will talk about auto discovery of nodes without actually having to hard code that into our cookbooks and the environment. So how do we do that? So roughly around 30 of us around the globe, we met in a GE training facility. We sat there, and our goal was to deliver a web-based application from infrastructure all the way up. So as we did that, we developed the principles, we overcame some challenges, and we were all equal players at that point. So we all had skin in the game in that sense. So as we move through the presentation, you'll see how we met these challenges, how we overcame them, and it really all starts with the operating system, and that's where we'll begin. So the entire stack starts with the OS, as you know, and we call it the Secure OS. So it's a blueprint that encompasses capital-wide security standards, industry best practices to harden our operating systems. So these components also support integration with the infrastructure nodes, the web tier, the app tier, and the database tier. So, you know, what is that blueprint made of? So on the screen, you can see there's a big eye chart, functional support that we use that are really utility cookbooks to help us drive that, and I'll talk about that in the next slide. User-based stuff, we use Chef, Secure Home, security settings such as SE Linux, our legal banners, disabling and locking services, Splunk, all that kind of stuff. So to paint a broader picture of what the Secure OS depth is, how many of you are familiar with like CIS audits or the DoD standard audits? So a few of you. So if you've looked at them, you know there's 300 some odd rules in there that you need to code for. So we basically took that, bed that into our corporate standards, and that makes up the Secure OS for the server hardening piece. So now all of these configurations that we manually had to change over the years and kind of review and go back over, they're managed with Chef. So we have variation is documented in the cookbooks, and now all that variation is managed. So we've eliminated the need for SOPs, there's no manual intervention, and it gives us the ability to quickly respond to audits. So managing drift, what does that really mean for the operating system? So if you see on the slide here, there's kind of a funny picture of the guy I like to call Jim that's there. He's surfing the drift, right? It's pretty funny, but he's kind of missed the point. He's on the shore. Shouldn't Jim be out there in the water trying to read the break, catch the next big wave, and see what Mother Nature is throwing at him so he can react? But instead, Jim's kind of floated along and he ends up on shore. So he's not really doing much. So here's what I mean in contextual terms. In today's world, most of us have golden images. We deploy them, and then you release it out to the application team, and what happens? They open up root, they add users that aren't supposed to be there, they add services, and you forget to lock those down. And you haven't gone through the proper identity management changes. The PM comes over to you and says, can you just get this done now? And then we'll put in a ticket, and we'll get that done later. How familiar is that, right? So, and here's a real situation around that. So while we were going through building the Secure OS, as we got to the web tier, we had to protect the front-end URL with SiteMinder. So as they're troubleshooting, trying to install, they come to the fact that, hey, the Secure OS has SE Linux enabled. So what do? What's their suggestion? Any guesses? Turn it off. Yeah, great. And what was my response? I don't think so, right? You're gonna have to make your application work with a Secure OS, and we're gonna build a framework from the bottom up. So now this brings us to the logic. How do we manage multiple business across the globe? How do we manage that data? So as G's, we're trying to strive to simplify our environment, trim our tool pates down, unify with Active Directory services, and we had a lot of hurdles to overcome for that. So how do I manage that disparate data? And secondly, how do I drive my cookbooks and my recipe logic to manage that large volume of data disparity? So, and the answer for that for us was, there's two cookbooks that we developed. One that's related to the business that does some pattern matching off the server nomenclature that we have that derives the business that it's from, its production state, whether it's prod, DR, QA, whatever, and what pole it lives in. Is it in the US? Is it in EMEA? Is it in Japan? So on and so forth. And then that feeds to another one that's called an organizational cookbook. And inside that cookbook itself, it contains server OU instructions, DNS configurations, NTP configurations, anything that's contained to that local sub-business. And so this also solved two problems for us. One, it's a source of truth for all the developers to obtain this information about all the sub-businesses. And more importantly, it negates the need for the developers to hard code business-specific values within their cookbooks. They just pull it from these two utility cookbooks, and we only have one point of extraction. So, now that we've kind of covered the secure OS and the foundation, my colleague Akash will talk about the Chef enabled from a bird's eye view from the OS up and what that means for the application.
Yeah. So what we thought about is that basically maybe it's a little bit deep dive, but it's better to understand what we are doing if we jump into the code a little bit and see how it looks like. And I'm gonna take the laptop here because I need to see some of the notes there. So basically the main idea is, if you see the diagram, it's a simple 3-tier architecture that everybody saw: web tier, up tier, DB tier. It's no magic there. But what we did, we basically identified 3 different layers that we wanted to manage consistently. The first one, as Rob already mentioned, the OS layer, so the secure OS, close all of the unnecessary port, take care all of the user access right control and everything that makes the box itself safe. So on top of that, we need some kind of engine that can host all of our application, all of the things that we are developing, and publish stuff on the internet. So we need some kind of cookbook that take care of the functionalities for the application tier, web tier, and or the database engine installation. So we introduced that blue tier there. That basically, if I just take an example for like application tier, even if you have different flavor of the application servers like JBoss, Tomcat, WebSphere, you can pick one. Each of the cookbook should install the binaries on the server, configure all of the proper configuration, all of the ports, all of the listeners, all of the JVMs, JVM variable size, everything. So that cookbook should do all of that job. And as part of the promise theory, what we thought about, we need to promise on that cookbook. So when I need to use one of these application server, one of the flavor, I have to be 100% certain that's going to be configured for me. And the next layer, which is introduced as a yellow layer, basically just the configuration driver that we call the application cookbook. So the application cookbook doesn't do any of the deep detail binary installations or configuring detail configuration files or own any of the configuration files. It just drives all of our needs, all of our configurations through the node attributes. And it is how we leverage the Chef server node attribute capabilities. And so when we started to introduce this concept, these functions, we realized we have some kind of data interface between the two cookbooks, which is similar than the SOA stuff. So we try to figure out how we can standardize some of the node attributes naming convention, a nice data structure for each of every cookbook. So basically that's easy to follow when you implement a new flavor, or as we have a big organization, as Rob mentioned earlier, one of the challenge, we wanted to leverage all of the teams, all of the people who wants to join us as a G internal open source community. It is how you can imagine that. And each of the contributions should be able to reusable. And so if we have some patterns, some things that each of every development team can follow, then we easily can use and introduce that new function, new cookbook as part of our family, our group. And it's also really easy to review and check all of the functionality that cookbooks provide if we have something that we can measure these things to. So we have two challenges there actually. I'm gonna talk about one, and Rob gonna talk about another. How we can keep the secret secure. So if we have these cookbooks and we interact between the cookbooks, then we still need to make sure, when you pass through some database passwords, for example, that's kept secure, and how we can manage that. So we're gonna cover that later. So the next slide, basically, I try to zoom in a little bit between two cookbooks interfaces. So how we can ensure the functionalities and capabilities across cookbooks when basically we opened up the opportunity to implement different flavors of each of the cookbooks. So I have a couple of examples. So imagine you have an Oracle database in your 3-tier environment and a Tomcat cookbook, and the business decide or the IT decide to move over to a JBoss because you need more functionality, more capabilities, and you still keep the Oracle behind. So in that case, we basically doesn't want to change anything in the cookbooks, doesn't want to change anything how the JNDI configurations happens. That should be part of the application cookbook. So what we did, we leveraged the search capability of Chef environment, and each of every application cookbook configure all of the static, relatively static, so from the Chef server point of view, static content, which comes from the node attributes, and then we run a search and find all of the nodes that serve that particular application as a database. And all of that database is going to be configured by the application cookbook dynamically using and leveraging the search capability. So for leveraging that, we obviously need a really solid, strong logical data model that everybody follows to make sure whenever I find a database server, I have to be 100% sure that database server provide the data for me in a certain structure, and that structure always the same. Even if I find a Postgres database or an Oracle database, each of them provides the data in the same way. We also wanted to leverage the Agile as a development methodology to make all of the releases much easier. We can have much frequent, much more robust development cycle there. And so all of these things, when merged together, we get an environment that I always call like a SOA-like environment. Then you have like all of the node attributes, all of the nodes publish themselves as a service provider, and you have service consumer, which is the next cookbook on the layer that's gonna basically leverage all of the data and implement all of the functionality the right way. So that's the way how we implement all of those interfaces, and obviously the challenge is still there, like how we can keep the secret secure. So if we move forward, yes. So I zoomed in a little bit more between the configuration file. I have a couple of examples for showing you how the data structure looks like, how the cookbooks communicate between each other. We have the same kind of interfacing and communication between the web tier and the up tier. And so when you introduce a new application server in your cluster, then the Apache server basically find that server in the same method, like using the search capability of the Chef. And based on the published attributes, which is start with the endpoints always, and then the next layer is the up tier, which is introduced. Okay, I'm an application server, and then after that you get all of the necessary information that helps or necessary or required for a reverse proxy configuration, for example, in the web tier side. And then the web tier cookbook just grab those information, merge together with all of the static configuration needs, and apply them in the same template, which is the HTTPD conf file in this case. The next example shows the same things, how it's happened in the database side. So when we have a database server, the database introduce itself again as an endpoint, and under the endpoint we have introduce the server itself as a DB tier. So when you do the search, it's really easy to do whenever you run that code in the application tier or the web tier, and then find all of the necessary information to configure your application cookbook using Oracle, for example. We believe that we had some argument inside how we're going to configure the JNDI, the JDBC drivers, And basically we ends up with a situation when we agreed on that the database team who built the database cookbook for us knows which JDBC driver is the best for that particular version that they're running on. So basically we have one of the attributes, as you can see, just pick one, which is the driver location. And that basically shows and provide a full URL for that particular JDBC driver. So we grab that as part of the application cookbook run and install it in the proper place where that particular application cookbook flavor wants. So if it's a JBoss, it's a different place. If it's a Tomcat, it's a different place. And obviously, if it's a WebSphere, then it's different again. So if we if you move forward, then I have one slide that is a little bit deep dive. It's like code. Sorry, it's really small, but you can download all of the presentation and you can analyze or see the code in detail. So what I try to show you in the left side, we have the code itself, the cookbook that implemented in the template. So within the template, we iterate through each of every finding after the search, node search, and parse all of the information. And basically, it is how it's become part of the template, which is the configuration file itself. So it's merged together all of the static configuration attributes as well as the dynamically find server attributes. So I also have another challenge for us, basically in another dimension. When we see these whole things, it's really nice, it works perfect, so everybody happy, we find the nodes, we are happily configured the application server that uses a database node, and then when we start talking about the full deliverance, how we basically implement codes, how we test them, we're going to introduce a lot of different sets of 3T architectures in our testing framework. So in that testing framework, when you are in the development environment, you obviously want to find only the nodes that belongs to a development environment for that application. So you never want to basically start using a node for a development or a testing that is in production, for example. So we had to create another set of principles or rules or like sample codes, how it needs to be used. And it's a really easy method within Chef. Thanks for the capabilities and actually OHI. When you run the search, you can basically actually you always know which environment you are running on, which scope you are running on. So basically we just embedded that information in. It is what you can see on the top of that code that basically grab the information I'm running on what, and then based on that I'm gonna configure that particular search for searching all of the node that is in the same role, same environment. And it is the way how we can get the little bit lower. You can see the code itself is basically find the proper union, dev, or production environment databases only and configure only them. So we solved that part of the problem. However, we still have some challenges around the security, as I mentioned to you earlier. So Rob's gonna talk about how we keep the secret secure and how we basically deal with all of the passwords and things that doesn't need to be published.
Thanks. So on this next screen, in our previous slide, we talked about the challenges I mentioned around secure identity transmission without hindering the ability to automate. So the guiding principle that we had was we needed an audible way to manage those identities. And to accomplish this, we used both Chef Databags and Chef Vault. So first we started by looking at the local users, and what you'll see depicted on the screen here is, we have a new developer in the group. She's kind of fancy there in her suit. She generates her OpenSSL password. It's encrypted. She provides us a user ID, and then we go ahead and add it to the data bag. And as that gets updated on the next Chef run, she now has access to all the servers and the nodes that she needs to have access to. So, and we also took the account, if you can see there's a bunch of different folders there, and we use data bags to control our OS systems accounts, our administrator accounts, web admins, DB admins, application admins, and then whitelisted accounts that are really based for secure users that have to do Qualys scans and Scabber reports and things like that. So we use this above method just to start when we originally started out, since there was just a handful of us. And now that the environment has kind of grown, we're now becoming more mature, and we're employing the Nix bridging solution to manage our software package and authentication between our Unix nodes and AD. But besides the AD fact, which I'll get into in just a minute, the managing secret parts that he talked about, is there's 3 vaults that are depicted here on the screen, and we use that functionality to pass like shared credentials to a chef recipe to enable it to do what it's going to do. So how many people in the audience know Centrify or UNAB? Likewise, they're all AD Nix bridging solutions, so just a handful of you. So the example behind that is the Centrify product. In order to join a machine to Active Directory, you have to have an account that has the privileges to join a machine from Unix to the domain. And previously, we had to do that with the script, and every user that came in had to put in his own user and ID that he had a valid credentials to do that. But now with Chef Vault, there's a service account, it's totally locked, it's encrypted, and that just gets passed through, and we're able to join the machines to the domain on every chef run that we do. So part of our run list, we run the Secure OS that I talked about, and then the add-on things, we add all our third-party software that we've done and added to cookbooks. Our Opsware node, Centrify, UNAB, Splunk. On the Windows side, it's McAfee and Sophos and Digital Guardian. So all those things happen that need those type of service accounts to actually install and configure are now done on the fly and automatically, and they're kept safe. And no one needs to know those passwords. Let's see. And that's exactly what I just talked about. I was behind on my slides. And so the summary of it all is, we talked about a fully automated operating system, the auto discovery of nodes for the applications, the standardization ontology for the logic that we use for both the organization and between the cookbooks, and then how we manage secrets across the enterprise for now. So this really sums up our talk here today. So we'd like to thank you for listening to G Capital, how we leverage the power of Chef to simplify, secure, automate, and streamline our infrastructure and our application environments to serve our business and ultimately get us faster time to market. So also, if you were intrigued by what you heard today during this presentation and would like to be part of the Capital journey, please see me after the break and we could talk about career opportunities with GA Capital. So this time I'll open the floor for questions, if there's any. Sure.
I've been down the road of doing automatic node discovery with Chef Search like that before, and the problem that I ran into was that the information that's kept in the Chef server is only written at the end of the Chef run. So a database comes up all the way. The last thing it does is it writes to the Chef server, which effectively is cached state about what nodes are alive and dead. Have you encountered like firefighting problems with liveness? If so, what is your strategy for taking care of that? I know some people go all the way down the road with like Zookeeper and other things like that. I didn't know if you had any strategies.
Yeah, actually what we try to use these things for is more like the knowing which data center we are running on. So we have a lot of data centers and we want to standardize all the cookbooks. So I don't want to be worried about move the entire application suite from a data center to another data center, and we don't want to change any of the code. So when you are in another data center, then obviously that data center is going to find those databases. So we don't use this method or these functions to basically like real-time managing the server accessibilities, because that's going to generate a lot of problems. So we use the same methods between the application servers. That is one of the layer above these things, this configuration. So all of the load balancing and real-time things is managed the layer above in load balancer or some other methods that the Oracle provides, for example.
Thank you.
Is it answers your question?
I'm sorry?
Is it answers your question?
Yes. It does.
Okay, perfect.
Yes, sir.
Yeah, sure. So what details you are looking for? Let me go over back to the slides that, oops. Okay, so basically what we try to, let me go there, just give me 1 sec, we're almost there. So, let me go back to this slide. So basically what we try to achieve is that whenever, actually one more slide back, sorry. It's easier to explain. So each of the blue layer, blue cookbooks, has its own role. So we know very well when we have an application server cookbook, then the application server gonna install the stuff and then configure everything that needs to be configured for deployable application. So when we have the search finds all of the data, all of the information that's required for the proper configuration. In the database case, all of the scheme, and I have the slides for the database sample. The next one. Yeah, if you see, I mean, it's maybe too small for and sorry for that, and you can download the slides then. So you can see we have a Fleet Mobile database, and we know it's a Postgres type of the things, and all of basically the connection strings can be built up based on the information that's provided by the database server. And if you go forward, then we have all of the IP addresses. Obviously, the password is empty because we use the Chef Vault for providing all of that information. The driver location to provide the proper JDBC driver under the application server, and that the driver itself going to be installed by the application server cookbook as just the information provider, and the host name that's also needs for the connection string for any of the driver config. And if you obviously use more than one databases or even more than one node of database, we have some applications that use 3 different kind of database, and each of the database has a couple of tables or table spaces. Then we have basically, as you see, the data structure. It's well structured, so you can configure all of them within one configuration file. No, we run frequently. So we have a setup, and each of the cookbook runs in a set period of time. And it is one of the things basically that helps us to self-heal all of the configuration, all of the application server. So if we have some hijacker who still brave enough to change something in the environment, then obviously we can make it self-heal.
Yeah, we also handle that, and because the organization is so large, and not all the applications that we're planning to migrate into the DevOps space can handle continuous delivery right now. So we have 4 different quadrants. So I can also deploy the secure OS and just have the OS be on a continuous basis and up to date. And then the web tier and app tier are also in another quadrant where we configure those, and the application is still static until they're ready to either migrate their code, rewrite their code, to get them into what we call the quadrant 4, which is the entire continuous delivery, the full stack. Yes, sir.
Talking about your 3 tiers there, how do you manage which functions go in which tier?
Very good question. We have I go back again. Just give me 1 sec. I have a slide for that. We have the yellow tier, which is basically we call application cookbook, which is not the application server cookbook. So when you have all of the capabilities implemented in each of every like blue cookbooks, if you like, that's basically the main engine room, if you like. Then each of the yellow, which is the application cookbook, drive all of the configuration needs to node attributes. And the way how we designed or structured the application cookbook, we have one application cookbook, and each of every tier has a recipe for it. So when you are in the web tier, then we include the same application cookbook, but with the specification for that particular like web tier recipe. And it is how we basically drive all of the proper and like special configuration for each of every tier.
And I understand that structure. It was more about beginning. You talked about application admin comes along and wants to turn off SE Linux.
Mm-hmm.
How do you prevent them from just throwing that in their application cookbook? And there it is.
Yeah, the way actually the promise theory again comes on board here. because within the application cookbook itself, we don't do any of the configuration, like physical things like the user file or any of the craziness that needs to be taken care of that in the OS, Secure OS cookbook. So we can drive like whitelisting users, for example, the JBoss user or the Tomcat user, but we are not like changing the user files or creating new users. It's on from the application cookbook. So that's done by the Secure OS cookbook. And if somebody tried to do that and include the Secure OS cookbook, then the first things that the Secure OS cookbook user recipe does is wipe all of the users done who is not part of the whitelist, which is driven by the proper node attribute.
There is actually something else that we do. So we have to do code reviews of all the stuff that actually goes into it. So
Yeah, obviously we do that. Yeah.
if somebody actually puts turn off passive limits in an application code, we'll see that and say, yeah, no,
that's real about it.
Oh yeah, okay.
Any other questions?
Follow up on that. What's the
Sure.
overhead of doing those code reviews? Did you have to have a human look at it?
Yeah, we talked about this in one of the other presentations that we did. We have to do a lot of automated code quality and such testing that we call them. So a lot of code doesn't actually make it. We have to actually get human review.
Well, when I'm thinking specifically about this topic, right, where somebody's trying to do a bad thing, right, it would pass all the syntax checks and all the automated checks.
It's not like because we can actually distribute that code in review. So if you've got a team that's say like 10 guys who are working on functionality, the team can do that.
Which makes sense because if they are owning that cookbook, they're familiar with it, so the one who review it is more suited to review it.
Correct.
And would ultimately be responsible for it.
Yes.
Yes.
They have to speak out.
Correct.
Absolutely.
And we also allow our code managers to look at this if they want to. The security guy can also say, hey, you actually left this. So it's not necessarily
Yeah.
what a change and fix that.
Good, thank you.
Any other questions? Yes. Yeah, it's a really good question. Actually, we always roll forward. We always roll forward, so we never do rollbacks. We just, if you find an issue, we can fix it. If it's just a bad node or some hijacker was able to, successfully do something that made the whole thing, die, then we just kill that node and spin up a new one based on the same exact configurations, like a clean node, and then introduce that as part of the family of the clusters based on one node attribute, which basically identify the application that we use that node for, and then everything else automatically happens based on this search and everything that I just explained. So it's really easy to replace a node or introduce new nodes or basically elastically configure the entire environment up and down. Did it answer your question? Perfect. Any other question?
Okay.
All right.
One thing I would add to what you said, Akash, is that because we do continuous delivery and continuous integration, it's so built around testing, the potential for those kind of problems that you described, I mean, of course, you're still learning new things like that, it should really be minimized, right? Because if we run it through into each environment and we do the right level of testing on it,
Yeah.
Yeah, we have to run continuous
Okay. So thank you
Thank
very
you so
much
much.
for your interest. Yeah. Thank you.